Hello everyone. Next concept is dominance property. So will be used for reducing the size of the matrix. So if the matrix size is given 3 by 3 or 3 by 4 size type of the matrix, in that matrix if the saddle point is not obtained, we will go for applying the dominance property to reduce the size of the matrix. For that, row wise reduction, column wise reduction as well as will be there to convert it in the form of a 2 by 2 matrix. The row wise reduction, by following this condition, we are going to reduce the size of the matrix. By using this condition, we are reducing the column wise. So if in case we are applying these two conditions also cannot able to reduce the matrix size into 2 by 2, we'll go for using these conditions, the row wise as well as column wise, to reduce the size of the matrix. So I'll explain these points to you with the help of example. So here matrix will be given, the help of 3 by 3 matrix is given. So 3 by 3 matrix is given. So 3 rows, 3 columns. We need to go for reducing this matrix into 2 by 2. So first thing is we will go for considering the saddle point. We'll find the saddle point here. So if the saddle point is obtained for us, there is no need to go for doing the dominance principle. So if the saddle point is not obtained for us, we will go for applying the mixed strategy. So that condition for applying the mixed strategy is the matrix size should be 2 by 2. But here the matrix size will be obtained for us will be the 3 by 3 matrix. We'll go for reducing one row as well as one column by applying the dominance principle. So the matrix will be going to convert it in the form of a 2 by 2 matrix. After that we can able to apply the mixed strategy concept to get the value of the game. Here in this problem we are not able to get the saddle point here. So we'll try to go for reducing the one row, one column to apply the mixed strategy. So here the condition is row wise total, column wise total. First we need to identify the row wise total as well as column wise total. First row, second row, third row. Total of these values will be obtained for us in the row wise total. After that we can go with the consideration of column wise total. First column total, second column total, third column total will be obtained for us. So based on this we are applying the conditions. First condition as well as second condition. So here the first condition by the row wise direction, ith row is less than equal to jth row. Row wise reduction we are applying here. So less than condition means minimum value we are considering here. Least value will be the 9. 9 may indicate as a ith row. I mean that A2 indicated as ith row. Next will be the jth row will be the either A1 or A3. Now the condition will be given. A2 will be the ith row. A1 will be the jth row. So one condition. Next condition is, this will be the one condition. Next condition is ith row will become as A2, jth row will be the A3. So by applying these elements, so here you can observe this clearly. Ith row elements, ith row will be the A2, 0 to 7. 0 to 7 will be considered is less than equal to A1 row. A1 row 172, 172. So we are applying the condition. 0 is less than 1, 2 is less than 7, 7 is less than 2. It is not possible. Means A2 is not dominated by the A1. Now A2 is dominated by A3. So now you can apply this condition. A2 elements, A3 elements. So if you are verifying that first condition is okay, but 0 is less than 5 is okay, 2 is less than 1. It is not possible. Means A2 is not dominated by the A3. Now you can apply the second least element. Second least element will be the 10. 10 will be going to compare with the remaining rows. 10 means A1 row will be compared with the A2, A3. A1 will become as a ith row, A2, A3 will become as a jth rows. Now applying the condition by using that same equation here. A1 will be the next least value. So now applying the conditions here, so verified with that. So here also not satisfied, so first condition itself, here also not satisfied. Now I can go with the next least value, that is A12. A3 will be the ith row, next will be the jth row. In this also not satisfied here, so matrix will be verified in the column wise. Column wise verification, ith row is less than greater than equal to jth row, ith column is greater than equal to jth column. Column wise we are going to consider with the maximum. Here the greater than will be there, greater than means maximum value will be considered here. So ith column will become as a b3 will be combined with the b1 as well as b2. If the elements will be satisfied here, means the b3 column will be deleted. So you can verify that 276 compared with the b1 0 105. So 2 is greater than 1, 7 is greater than 0, 6 is greater than 5. So three conditions were satisfied here, means b1 is dominating the b3. So b3 is deleted, so after deleting of it, the revised matrix will be, we can to go this one, b1 b2 b3 is deleted. Now you can repeat the procedure again. Row wise total, column wise total. Row wise total, 1 plus 7 will be the 8, 0 plus 2, 1 plus 6, 5 plus 1, 6. So now apply the condition, ith row is less than equal to jth row. So a2 less than a1. A2 is the least value. So compared with that, so those two elements was deleted here. The condition was satisfied, 0 is less than equal to 1, 2 is less than 7. So means a2 is dominated by a1. A2 will be deleted. So two rows will, one column will be deleted as well as one row also will be deleted. The revised matrix will be a1 a3 b1 b2. It was shown for us here, the payoff matrix. So for this payoff matrix, it will be converted in the form of a 2 by 2 matrix. Now we can apply the mixed strategy. So in that, first we will go for finding the oddments. The matrix will be converted into 2 by 2 matrix. Now we are applying the probability, that mixed strategy. So finding the oddments, maximum payoff value minus minimum payoff value. So that revised matrix. So here 7 minus 1 will be represented in the opposite position, 5 minus 1 will be represented in the opposite position. So same way in the column wise also, 7 maximum minus minimum, 7 minus 1 6, maximum minus 1 minimum, 5 minus 1 4. Total value will be 6 plus 4, 6 plus 4 10. That matrix also will be shown to you here in the tabular column. Next will be finding the oddments in the given matrix. Oddments will be calculated. Need to find the probabilities. A1 probability will be 4 by 10. 4 by 10 means 4 by 10 will be obtained. A3 probability will be the P3, 6 by 10. So will be shown to you here. Next Q1, B1 probability is Q1, 6 by 10. That will be shown to you here in this position. Next will be the 4 by 10. So 4 divided by 10, that will be shown to you here. That is B2's probability. Next will be finding the value of the game. The value of the game is 1 into 4 plus 5 into 6 divided by 10. So that is the value of the game will be obtained to you in this one. That is 17 by 5. Now whatever the probabilities value will be obtained to you, in the mixed strategy, sum of all the probabilities will be equal to 1. So A1, A3, that probability will be 4 by 10, 6 by 10. So that will be equal to 1, sum of these two. So in the B1, B2, B3 probabilities, sum of these values 4 by 10 plus 6 by 10 will be also equal to 1. This is about the dominance principle in a problem. The next problem we will apply the another simple another problem. We will try to do that with a different case by applying the third condition also will be used in the next problem. The matrix will be given 4 by 4 matrix here. So first we will try to go for finding the saddle point for this problem. So we are trying to find the saddle point. So in this, saddle point is not obtained. Row wise minimum, column wise maximum we are identified. There is no max mini or minimax value is not equal. So there is no saddle point here. So we need to go for reducing the size of the matrix into 2 by 2. Why? Because it is comes under the mixed strategy. So in this one, first step is row wise total, column wise total. We need to calculate that. So row wise total also, column wise total also we did here. So first row total will be the 9, second row total will be 13, third row total will be 10, fourth row total will be 12. Column wise also 10, second column, third column, fourth column will be made, that one be total will be calculation. Next thing is row wise minimum. Which is the row wise minimum here? The total values 9 will be the minimum. 9 means A1 row is selected here, will be subtracted with the will be condition. We are applying the condition here. A1 will be the ith row, A1 will be the ith row, jth rows will be A2, A3, A4. We are going to compare with that. So if any row is dominating with that A1 row, A1 will be deleted. So here the conditions will be given. So based on the payoff matrix. So here 3240 is less than equal to A2. 3424. So all the elements is not dominated by A2. So next we can go with the A1 compared with the A3. A1 with A3 comparison. So all the elements was dominated here. Each and every element is dominated. So means A3 is dominating the A1. So means A1 will be deleted. A1 will be deleted. That revised matrix will be shown to you in the next one. Revised payoff matrix. After deleting the A1, the revised payoff matrix will be A2, A3, A4. So now again we need to apply the condition. Row wise total, we need to repeat the procedure. Row wise total, again we have to calculate. Row wise total, we need to calculate again ith row. So in that least value will be the 10, means A3 will become as a ith row, A2, A4 will become as a jth rows. A3 is less than equal to A2, A3 is less than equal to A4. So now we are doing this calculation here. A3, A4, A3. So in this first element itself not balanced. So A2, A3. So next A3 is compared with the A4. So it is also will be rejected. Next least element will be the 12. 12 means 0 is less than equal to A2. I mean that 3. 4 is less than 4. Equal to 4. 0 is less than equal to 2. Not possible. So condition is not satisfied. 0 is less than 2. Okay. 8 is less than 4. Sorry for that. 0 is less than 3. Okay. 4 is less than 4. Next will be 0 less than equal to 2. Okay. Next will be 8 less than equal to 4. It is not possible. The condition is deleted. This is also not applicable. Next A4. A4 with A3. A4 with A3 also compared. 0 is less than 4. Okay. 0 is less than 4. Okay. 4 is less than 2. Not possible. Condition is rejected. Next list will be the 13. Means A2 will become as a ith row. A3, A4 will become as a jth rows. A3 less than equal to A2 less than equal to A3. So in that also not possible to relate the rows. Now we can apply the column wise direction. Column wise direction, first column we need to select it as a maximum. Maximum is 12. 12 means B4. B4 will be the greater than equal to B1, B2, B3. So that condition was shown to you. here. So that conditions also not satisfied here, that three conditions also not satisfied. So next highest will be the 10. 10 will be selected, that means 10 is B2. B2 is greater than equal to B1, B3, B4. B1, B3, B1, B3, B4. That 3 also not satisfied here. Next list will be the B1. B1 is less than equal to B2. Sorry, B1 greater than B2, B1 greater than B3, B1 greater than B4. So in that first condition is not satisfied, but second condition will be satisfied. All the elements was dominating. Here means B3 is dominates the B1. So B1 can be deleted. So that revised matrix will be shown to you in the next page. B1 is deleted, A1 also will be deleted. Now the matrix is become as a 3 by 3 matrix. So our aim is to convert it in the 2 by 2 matrix. One row will be deleted, one column will be deleted. Again we need to do one more step, that is we will go for reducing the one more row as well as one more column. So in that again we are repeating row wise as well as column wise. In the row wise list will be the 6. 6 means A3 I is less than equal to A2 or A4. So that 2 also not dominated here. Next list will be the 10 A2. A2 will be less than equal to A3 or A4. So that 2 also not dominated. Next list will be the 12. A4 will become as ith row. Will be less than equal to A2, A3. That 2 also not dominated. Now you can apply the column wise direction. Row wise will be completed. Apply the column wise direction. Column wise maximum will be the 12. B4 is greater than equal to B2. B4 is greater than equal to B3. So that two conditions also not satisfied. Next highest value will be the 10. 10 means B2. That also not satisfied. Column wise also not possible to delete the columns. So next thing is how to reduce the matrix into 2 by 2. One more option will be there for us, that is average of 2 rows or 2 columns. The row wise will be verified. The row wise it is not possible to reduce the rows by making the average of it also. Now I am applying in the column wise direction. B2 is greater than equal to B3 plus B4 by 2. Average of B3, B4. So we'll be getting as a matrix will be like this. 4 to 4, that is B2. 4 to 4, that is B2. Now compared with the average of these two. 4 greater than equal to 3, okay. 2 is greater than equal to 2, okay. 4 is greater than equal to 4, condition is okay. Means you can able to delete the B2. B2 is dominated by B3, B4, average of B3, B4. Now the revised matrix will be shown to you here after deleting the B2. Now I can able to reduce the one row. I can try to go for reducing the one row, that is either it may be A2, A3, A2 or A3 or A4. I will go for averaging of this procedure in the row wise also. A2 is less than equal to A3 plus A4 by 2. I can able to get the values like this. So in this A3, A4 average was dominating the A2. A2 will be deleted. The revised matrix will be shown to you in the next one. That is converted into 2 by 2. Here the matrix was converted into 2 by 2 payoff matrix. So now we are applying the mixed strategy concept for finding the odd bends. So probabilities as well as value of the game. So in this odd bends calculation, maximum minus minimum will be represented in the opposite position. 4 minus 0 will be the 4. 8 minus 0 will be the 8. 8 minus 0 will be the 8 in the opposite position. 4 minus 0 will be in the 4 opposite position. Sum of these two, 8 plus 4 equal to 12. 8 plus 4 equal to 12. Now I am going to find the probabilities. A1 probability will be the P3. A4 probability will be the P4. That is 8 by 12 will be the probability of it. Next 4 by 12 will be the P4 probability. The Q1 also 8 by 12, that is getting will be Q3 probability for B3. B4 probability is Q4, it is 4 by 12. If you are making simplification, that is will be getting to you 1 by 3. Now you can able to find the value of the game. That value of the game will be 4 into 8, 0 plus 0 into 4 divided by 12. I'll repeat it again. 4 into 8 plus 0 into 4 divided by 12. You'll get the value of the game. So it will be shown to you here. That is 8 by 3. So probability values will be we are calculated. So that is 2 by 3, 1 by 4. That is P3, P4. P3, P4 values will be 2 by 3, 1 by 3. That is will be obtained for us equal to 1. That means next probability will be 2 by 3, 1 by 3. So that is equal to 1. You get the value of the game will be 1. Sum of these two probabilities 2 by 3 plus 1 by 3 equal to 1. We'll be simplifying of it. You'll get the value of the game. The mixed strategy concept is sum of the probabilities will be getting equal to 1. So is obtained here. Means game will be getting the value of the game also. Thank you.